All right, my friends, we're going to dive into some IP version 6 here in just a moment, and a very small rant to begin with. And if you've heard this before, if you've watched this video, you're entitled to go forward about 90 seconds or so, however long this takes. Just the rant here. Those of you who've read my stuff for a while, you know that I'm not some Cisco press basher or a Cisco basher. If I didn't like them, if I didn't like Cisco stuff, I wouldn't be doing this. I love Cisco stuff. And Cisco Press authors, very talented people. Having said that, the one thing that it's not necessarily something Cisco Press has done wrong. It's just that Cisco's certification program as a whole, in my opinion, has not pushed IP version 6 the way they should. And the problem is, this has been around for a decade now. And in the exams, like in the NA, you got to learn some fundamentals, some of which we're going to look at here. In the NP route, you do a little bit of work with OSPF version 3, which is the IP version 6 version of OSPF. But there's no, frankly, I think they just need a CCNA certification in IP version 6. I really do. Actually, I'm working on a course kind of like that. It's not for a specific certification, but I'm going to put that on Udemy in the summer of 2013, possibly a little earlier, because everybody needs to know some IP version 6. And for those of you who think your network's never going to use it, a little bit of a history lesson. This always reminds me of when Windows had a little product called Windows NT Server, and everybody used it. And it was around for a long time. And when Windows announced they were moving up in version, coming out with a new version of their operating system for networking, and that the MCSE for an NT server wasn't going to be valid anymore, I was just astonished at how many people threw a fit. And we didn't even have all the different social media methods of throwing fits that we have today. People lost their minds. And I saw people actually saying stuff like, well, my network uses NT server and it always is. You know better than that now, and certainly I know better than that. We all know better than that. This is a business of change. Nothing we're using right now is going to be the staple in networking 10 years from now. So if you've kind of told yourself, you don't need to learn IP version 6. I do not mean to be harsh when I say this. You're fooling yourself. You do need to learn it, and you're going to need to learn it. Because in the future, there are going to be two classes of network admins. Those who can work with it, those who can't. You don't want to be one of those can'ts. Now, having said that, we're going to go over some fundamentals here of IP version 6, a little beyond security. Because frankly, most of the security principles that you've learned, if not all of them, for version 4, IP version 4 in this course, you're going to be able to apply to IP version 6. Of course, there are going to be some differences, but I want you to have a little bit more than just saying, okay, here's some security best practices for version 4, etc. Let's look at some fundamentals here in this part of the course with IP version 6. And remember when you first learned subnetting and you first learned binary or hex? That's the way it was with me with hex when I first looked at it many years ago. I was like, what do you mean B equals 11? How the heck does B equal 11? This must be some kind of super secret calculus algebra type algorithm thing. And it wasn't. It was very simple. But I didn't know it yet, so there's anxiety with that. And I still remember, I don't mind telling you this, exactly what my reaction was when someone first told me about, oh yeah, there's a new IP version coming out, version 6. And of course, I was in the middle of prepping for the IE lab at the time. That's not the time you want to hear about any major changes in technology, right? And I just remember thinking, well, it's just going to be 2 more octets, tacked on the back of the 4 we already have, right? And I actually thought that. No. IP version 6 addresses are 128-bit addresses. And that's where a lot of the anxiety comes in. I just think the first time someone sees an IP version 6 address, they go, oh, what does this mean? Well, you'll get over that, because now just as you work with hex or with binary with subnetting and you don't give it a ton of thought, you'll be the same with IP version 6. It's just new and it's frightening looking. Those addresses are long, but they can be worked with, and we're going to learn how to do that. Now, the 128 bits, first off, what it means is that it's going to be quite a while before we have to worry about running out of IP addresses again. We learn all about NAT in the CCNA, and we do a little bit of it in the NA security course as well, but we forget why it was developed in the first place. And really the reason was because we were running out of routable addresses. we were running out of IP version 4 addresses. We had to do something. And since we're not going to have that problem for a while with version 6, it's farewell to NAT. You're not going to be using network address translation with IP version 6. Now, there's a version of NAT that can be used to help with the migration from IP version 4 to IP version 6. We're not going to cover any migration techniques here. That's in another course. And it's also going to be in one I'm doing for Udemy this summer, the one I mentioned. Because these are things you need to know about. And that's really where more anxiety comes in. It's not necessarily learning IP version 6. It's like, how in the world are we going to move from version 4 to version 6? Well, there are organized methods of doing that. But once you do it, you're not going to be using NAT anymore. A couple of other differences between these two versions, along with some other notes. Those broadcasts, those terrible, awful broadcasts that I'm warning you about in your CSENT studies, right? We're trying to limit their scope. You can't eliminate broadcasts, but you don't want unnecessary ones. Well, they're actually gone. IP version 6 does not use broadcasts. As I mentioned again here on the board, NAT was developed with the address shortage in mind, and it was imminent at the time. So we're not going to need it with version 6. Even better, IP version 6 was specifically designed with route aggregation / summarization in mind. IP version 4 was not. And occasionally when I used to do summarization of addresses, I like that stuff. I like getting into the numbers and the binary and seeing, how well I can summarize a given number of routes. But you do think to yourself on occasion, man, does this have to be this hard? Can't we do better? Well, we do better with version 6. And those of you who have taken courses with me before, I'm always talking about those routing tables being complete and concise. And IP version 6 is specifically designed with aggregation in mind. Now, DHCP, it's still around in version 6, but version 6 nodes can also assign themselves an address without the help of a DHCP server via something we call auto configuration. I want you to know about that. You might not see it on your NA security exam, but I am definitely going to discuss with you the auto configuration process here in just a moment. Now let's talk about those address formats and types, because as I said, I honestly think most of the anxiety about version 6 just comes from the fact that the addresses are 128 bits long. You will be very happy to know, though, this does not mean that you have to type out a 120-digit number every single time that you write an IP version 6 address, or even a slightly shorter one. We have something called zero compression and leading zero compression, and I'll tell you what I'm going to do. Those topics are definitely not going to be on your NA security exam, but a couple of compressions, you're going to see them in address ranges I give you here in a moment. I want you to know exactly what's going on with zero compression and leading zero compression, so I'm going to do a bonus video and put it in the course right after the regular IP version 6 discussion, and it'll show you exactly how to do zero compression and leading zero compression. It's good bonus stuff for you to know. Now, we know those version 4 address types. We got our unicast, represents a single host. Multicast represents a group of hosts. And broadcast represents all of our hosts. Well, again, we still have unicast and multicast with version 6, but broadcasts are gone. And we do have a different kind of address, different kind of message, anycasts. It's an address that represents multiple interfaces. Now, we also have different kinds of unicast addresses. The official name of the first kind is Aggregatable Global Unicast Address. And thankfully, we usually leave aggregatable off. This address, the Global Unicast Address, the name is the recipe. It's equivalent to the version 4 public address classes. They're fully routable and they can be summarized efficiently. Now, we've got something new here called the IP version 6 link local address. And it's an address that is kept on the local link. Makes perfect sense, right? Well, that's the address a host is going to use to communicate with other hosts on the same local network. Now, you can identify several classes of IP version 6 addresses by their initial bits. I put an ES there, sorry about that. 001, it's a global address. 8 ones, it's a multicast address. 7 ones followed by a 0 followed by 2 ones, is our link local address. Now our loopback, and this is the first time you're seeing the zero compression, 2 colons followed by a 1. Now, that's a pretty odd way, of expressing one. Again, the anxiety comes, it's like, what the heck do the 2 colons mean? Well, in the zero compression, leading zero compression bonus video, I'm going to show you. I'm going to show you exactly what that is. It's easy to work with, and for other exams too, it's going to be easy points for you. Because that loopback address is 127 zeros followed by a 1. Now, I love typing. I don't mind typing. I'm very good at it. I don't want to type 127 zeros in a row. Do you? So, you lose count, halfway through. 61, 62, 63, huh? What? Oh! So we're not going to have to type it like that. It's 2 colons followed by a 1. Here are some other additional link local addresses worth noting, and pardon the screaming when I mention nodes and routers here. But notice all these addresses begin with FF02 followed by those 2 colons. 1 is all nodes on the local link. 2, all routers on the local link. 9, all RIP routers on the local link. And A, all EIGRP routers on the local link. Do you see a way to remember those last 2? What is the IP version 4 multicast address for RIP end with? Yeah, 9. And what does EIGRPs end with? 10. And of course that's A, because here we are using hexadecimal. Now, any version 6 address you see with the first 96 bits set to 0, it's a version 4 compatible address. Now let's talk about auto configuration here. This is version 6's answer to version 4's DHCP, and there are 2 main types of auto configuration. You have stateless and you have stateful. Now, stateful auto configuration is used when a host gets a version 6 address and other information from a server. Well, that sounds pretty familiar. Well, that is DHCP version 6, usually referred to as stateful auto configuration. Now, we know with that point of failure, if that server goes down, we have no way to assign addresses, and of course, we know now, being totally paranoid, from a security course, that anytime we have extra conversations involved, there's always the chance of an intruder eavesdropping. And there's no such dependency on an extra server with stateless auto configuration, and the entire process begins with the version 6 host configuring its own link local address. Now let's break down that 128-bit address when stateless auto configuration is in use. The first 64 bits of this self-generated address is FE80, 7 ones, 0, 1, 0, followed by 54 zeros. The last 64 bits are what we refer to as the interface identifier. That's where we get the last 64 bits from. Now, at this point, when the host has basically calculated its own address, technically that address is tentative. Now, the calculation doesn't take any time, but we have to make sure that no other host is, for some reason, using that same address. It's a very quick process, and we're going to do it with DAD, duplicate address detection. And what happens here is that the host sends a neighbor solicitation message, an NS, to see if any other host on the link is using that same link local address. Basically, you know what the host is doing? The host is asking all the other hosts on the link, is anybody else using this address I just gave myself? And what we're hoping for there is silence. Because if we get a response in the form of a neighbor advertisement back from one of these PCs here on the link, that means that that particular host is already using that address. And when the host that sent the neighbor solicitation receives that NA message, then that host will then disable its link local address. If we get a response in the form of silence, well, that's what we want, because that means that no one else on that link is using that address, and the local link is the local host is satisfied that it has a unique link local address. Now, there's one more message to be sent out here. It's called a router solicitation message. The host sends out the RS message onto the link, and note the destination here. It's FF02 2:2, the all routers multicast address. We just want all the routers to hear this. We don't need the other hosts on the link to hear it. It's router solicitation. What's the host soliciting here? Well, it wants to solicit additional configuration information from the router to complete its address, and that will be sent back to the host in a router advertisement, an RA. Now, these RA messages are also sent periodically onto links without express requests from new hosts. It's just that when the new host goes ahead and sends an RS out, it speeds up the entire overall process. Now, the information in that RA includes the following. 1, flags indicating whether the host should use DHCP for addressing information. Then if DHCP is in use, the RA tells the host where that version 6 server is. If DHCP is not in use, the RA contains the needed network prefix and prefix lifetime information. And in the case of number 3, the router attaches the network prefix to the host's link local address, and then the host has a full IPv6 address. Pretty sweet. I'm going to wrap this video up here with talking about practicing our practices, and that's our best practices, that is. Because really, the security issues that we face with IP version 4 networks are going to follow us to version 6 networks. We still have to worry about eavesdropping, snooping, and man-in-the-middle attacks. Basically, the wrong people listening to our conversations and data exchanges. We still have to worry about people being where they shouldn't be. Whether that be a well-meaning employee who has too many permissions and gets files they shouldn't need or shouldn't have access to, or intruders. We still have to worry about denial of service attacks and distributed denial of service attacks. And we still have to worry about those low-down lying packets. And by that I mean spoofed. I don't think you're going to see low-down lying packets on the exam, but you'll probably see spoofed mentioned. Many of the defenses that we've learned in this course are going to go right along with version 6. The physical layer is the physical layer. I don't care what version of IP you're running, you block your server room up. The IP versions, the IP version 6 versions of RIP and EIGRP and OSPF, they've all got some kind of authentication built in there somewhere. Use them. And again, after that, I'm not going to repeat everything that we've done in this course. But if you're not using a service, shut it off. Shut it down. If you're not using a port, shut it down. Again, users shouldn't have access to things they don't need and shouldn't have permissions they shouldn't be using. It really is that simple. So again, it's just all, I don't want to say just all common sense, because a lot of it, of course, is common sense applied with what you've learned in this course. But when it comes to version 6, while I'm sure there will be specialized attacks to try to take advantage of things that version 6 does differently than version 4, it's still all about the fundamentals and everything that you've learned to date in this course. Secure that physical layer. Shut those ports down. Use authentication whenever you can. Don't send things clear text. Don't get a third party involved in a conversation if you don't need to. If you can use stateless auto configuration with DHCP, and take the DHCP server out of this entire mix, then by golly, you do it. That's just that simple. That is going to wrap up this particular video for IP version 6. Like I said, what I'll do next is prepare a separate video on zero compression and leading zero compression. It's not required for the IP version, for the CCNA security exam, but it's definitely required to work with IP version 6. So I hope you enjoy that, and I'll see you there.